Chapter 5 Atmospheric Structure and Radiation Transfer. Section 5.3 Atmospheric Layers. So we can suggest that the atmosphere is composed of a number of vertical layers. And we can define these layers according to changes in air temperature or changes in the chemical composition of the air with altitude. The following figure shows the layers in the atmosphere that exist because of changes in temperature. The major layers are the troposphere, the stratosphere, the mesosphere, and the thermosphere. In between these layers are transition zones, and these zones are called, between the troposphere and the stratosphere, the tropopause, between the stratosphere and the mesosphere, the stratopause, and between the mesosphere and the thermosphere, the mesopause. So we can see that there's four major layers as differentiated by temperature. From the Earth's surface to approximately 11 kilometers is the troposphere. Now I say approximately 11 kilometers. It's actually thinner near the poles and much thicker at the equator. And this is because of the temperature of the air. Warmer air expands. About 80% of the total mass of the atmosphere, the Earth's entire atmosphere, is just found in this one layer. This is also the layer where the majority of the weather that we experience occurs. In this layer, what defines this layer is that maximum temperature occurs near the Earth's surface, and temperature decreases as you move up in altitude. Now here's an example of one of the major features that exist in the troposphere. This is a thunderstorm, and the top of it is limited by the top of the troposphere. It does not extend much further than the top of the troposphere. Now I told you that temperature decreases with altitude. The average value for this decrease with altitude is approximately 6.5 degrees Celsius per 1,000 meters. And this is known as the environmental lapse rate, or ELR for short. Now, this is the average value. Sometimes it's higher than this value, sometimes it's lower than this value. The tropopause is the boundary layer separating the troposphere from the stratosphere. It's also the layer where the center of the jet streams exist. And we'll talk more about the jet streams later on in the course. So far we've talked about the bottom layer, the troposphere, and then that transitions layer, the tropopause. Above the tropopause is the stratosphere. The stratosphere extends from an average altitude of 11 to 50 kilometers above the Earth's surface. What's unique about this layer that's different than the troposphere is that temperature increases with altitude. And this increase is because primarily that there is a concentration of ozone gas. So if the temperature is increasing, that's indicating that heat energy is being generated. And this heat energy comes from the absorption of ultraviolet radiation from the sun by ozone molecules. This creates the heat and makes this temperature, or this layer, warmer than the air beneath it. The ozone layer is important to life. UV radiation is harmful to life, so it's a good thing the ozone is there, the heat energy is being created, because less ultraviolet radiation passes through to the Earth's surface, where it could affect us and other living forms. Now, between the stratosphere and the mesosphere is the stratopause. It's just a boundary layer. Above the stratopause is the mesosphere. This is the coldest layer in the Earth's atmosphere. Temperatures can get as low as minus 90 degrees Celsius in this layer. And it reaches a maximum height of about 80 kilometers. Above the mesosphere is another transition layer, and this layer is called the mesopause. Now, the last layer, according to temperature, is the thermosphere. And it has an altitude greater than 80 kilometers, and slowly it becomes less and less thick with gas molecules as it blends into space. This layer actually has an extreme temperature. Once again, heat energy is being generated, and this time it's just normal oxygen molecules are absorbing solar radiation. The temperature in this layer can approach 1200 degrees Celsius. Now this is strange because this is the layer that actually astronauts float around in when we see them sometimes in space. So why don't the astronauts burn up? Well, the molecules are increasing to this temperature, 1200 degrees Celsius, but there's so few of them that they don't rapidly transfer any heat energy to an object like an astronaut in that layer. It would take many years for that astronaut to heat up to a temperature of 1200 degrees Celsius. Now, I told you we can also organize the atmosphere by chemistry, and we have two general layers in here. The homosphere, which indicates that the gases in this layer are equally mixed. We're talking about the nitrogen, the argon, the oxygen, carbon dioxide, the 11 gases that were in our table. They're mixed in this homosphere. And above the homosphere, we have the heterosphere, and within the heterosphere, there are 4 layers. And this is where particular gas molecules concentrate. In the lower part of the heterosphere, we have a concentration of nitrogen. It's a heavy molecule. Then above the nitrogen is a layer of oxygen. And then above that is the lighter element, helium. And then finally, at the edge of the heterosphere is a concentration of hydrogen molecules. We can also suggest that there's other chemical layers. There's the ionosphere, so many ions in this layer. They play a very important role in bouncing radio signals. And between roughly 11 kilometers and 50 kilometers, we have a concentration of ozone gas, so the ozone layer.